Hi everybody, welcome to Pixopalooza session 11. Today we'll be talking about object tracking. Nice to see so many of you joining in. Hope you're all staying healthy and relatively sane during this global lockdown. I'm Andreas, I'm the project manager at the Future Group. I've been here for over 3 years now. And before that, I worked in game design for 10 years and 4 years as a test engineer. Just a quick reminder for those of you who are joining us for the first time or who missed the intro session. Pixotope is a real-time mixed reality virtual production solution built on Unreal Engine 4. It handles virtual studios, augmented reality, and hybrid scenarios. In our opinion, it offers unparalleled creative freedom. So if you missed any of the previous sessions, just get in touch with the person who invited you and they can provide you with the videos of these sessions. But today we'll be joined by stYpe, who are going to demonstrate object tracking. They will cover the technical aspects of the stYpe follower. Then we'll go to the UK to see how the interface works in Pixotope. And finally, we'll jump all the way across the Atlantic totally carbon-free to visit All of It Now in San Francisco, who will take us on a creative tour of how to use the stYpe follower within Pixotope. Throughout the session, if you have any questions, please feel free to use the questions panel in the GoToWebinar software, and we will get to them. We'll also cover all questions at the end of the session, so please just ask away. And since the internet is saturated everywhere these days, we'll be running a smaller webcam output to demonstrate high frame rates. We will also be providing you with a video of the seminar once it's ready, so you can study it at your leisure. So first up, stYpe will be giving us a walkthrough of their technology. We worked with stYpe on a number of very demanding outside broadcast productions, Eurovision, Red Bull Rampage, League of Legends twice now, and they've never failed to deliver. Let me see if I can find Ivan, see if he's ready. Ivan, can you hear me?
Yeah, I can hear you now, Andres. Can you
Awesome.
hear me and see me?
Yeah, you sound great. Okay, I'm gonna hand things over to Ivan. Take it from here.
Okay, amazing. Thank you, Andres, for the nice introduction. It's a pleasure to be part of this Pixotope webinar series. Like Andres said, we have a history of some really interesting projects, and in these projects we learned that we share like similar passion for innovation and offering highest quality modern stuff to our clients. So my name is Ivan. I work with stYpe for 7 years. I'll be talking to you about object tracking here, especially about the technology part of it, because we developed the hardware to enable object tracking. And then David from Pixotope will explain about integration, and the guys from All of It Now will show some really amazing creative stuff. So I think you will be really excited by the end of this webinar. So what is object tracking? In order to explain it a little better, I want to show like more the bigger picture, because usually each new product is supposed to solve some existing problem or bring things to a higher level. So we at stYpe, we started as a camera tracking company. So up until 1 year ago, at last year's NAB, when we launched this object tracking, we were exclusively camera tracking company. We started with tracking the cranes with just mechanical sensors on cranes. Later, we wanted to give more freedom to TV stations and film industry. So we wanted to be able to track steady cams, handheld cameras, and we developed our optical tracking system, which uses markers to track the camera. So what is camera tracking? Camera tracking is pretty much being able to move the camera. If my colleague moves the camera around, you will see that virtual elements match the real elements. So this table here is real. I'm a Homo sapiens real person, and the graphics and the real objects, real elements are matching. So let's show a quick look how the studio actually looks, just to see. Yeah, so this is an improvised set to be able to reach our clients during these lockdowns and things like those. And let's switch back to the virtual. And I'm sure most of you are familiar that you can get a really huge studio if we pan around a little bit, just because we can use camera tracking and a nice rendering engine like Pixotope. So this looks much bigger than it is. Okay, so this is how we started, how we reached this point. And I will show in a very real example, if we load a graphic over here, why object tracking is needed if you want to bring things to a higher level. So let's bring it to the table. Okay, so this is something you might see in a live TV show. So don't forget, all of this is about live stuff. If you have a lot of time, like months, to do things in post-production, then things are easier. Even Avatar was made with a lot of post-production. But if you want things in real time, then you need some really high-quality equipment. But without object tracking, you would still see presenters in live TV shows always have like a no man's land between them and the graphics, because they don't want to reach for the graphics because it doesn't look really good. You can't interact. You will see them be positioned behind the graphics, this will look good. But if they want to walk in front of the graphics, it will not be possible. That was simply the limitation of this whole industry until last year. And then since we launched our follower product, some of these things have been pretty much revolutionized. And I'm inviting my colleague Angela to join me, and she'll bring with her some really cool gadgets. And with these gadgets, we will solve. Okay, let's. Sorry. Let's turn off the cross mark, please. Okay, so let's focus on the hardware first. So she brought a few elements here, and all of them have one common, some common elements. So there's usually an LED beacon. There's always an LED beacon and a battery pack. We have these bigger battery packs. The biggest one actually is this one with 12 ports. This is follower pen, and the last one is this cube. So let's see some of the things we can do with it. Can you? Yeah, Angela has another one of these beacons. So if we turn it on, can you turn it on?
Yes,
okay, it's turned on. So let's see what's something new that she can do with this. We are using this to track her position. So Angela, can you walk in front of the graphic? As you can see, she's able to stand in front of the graphic. She can even partially cover the graphic, and it will be rendered exactly following her silhouette, because we are using green screen over here. So I still can't do it because my position is not tracked. But if I take this beacon from Angela, then I will be able to stand in front of the graphic. Okay. One cool thing is that she can even put it in her pocket because it goes through the fabric. So if she walks in front again, she can still do it. Okay. Another thing, you may have noticed an object here on our table. This is a normal presenter tablet, except it has 4 of these LED beacons on each edge of the tablet. And we are using those to track the position of the tablet. So Angela, can you show what we can do with it? As you can see, this virtual object is now behaving very, very similar as a real physical object. She's carrying it around. We're tracking the position. We're tracking the rotations in all 3 axes. She could turn around, and it's acting as a physical object. So some of those barriers that I talked about before, the no man's land between the graphic, it simply doesn't exist anymore. She puts a beacon in her pocket to track her position, and we are tracking this 3D object, and she can act much more spontaneously and deliver the latest news about the coronavirus, about the ecological situation. You can put any graphics you want. It's up to your designer team, and the guys from All of It Now will show much better examples about that. Okay, thanks, Angela. Let me just take the person tracker. Okay, thank you. So I will keep it in my pocket to keep tracking my position. And now I want to show just how accurate this tracking is. So I will use this other beacon. If we can switch off the Earth and turn on this. Okay. So in this case, we are tracking this one LED. In this case, we are tracking just X, Y, and Z because you need 3 or more LEDs to track rotations. But I just want to show how fast this tracking is. As you can see, I'm making like random movements, and the graphics stick to the LED. Okay, we can turn it off. Actually, let's keep it on. So how does it work? So this LED is powered by a battery pack, can come in different sizes, like I mentioned, and they are emitting infrared LED lights. And we have follower cameras placed around the studio. And in each moment, at least 2 of these cameras need to be able to see the LED. And once they see it, they find the position in X, Y, and Z space. Usually, we recommend putting more than 2 cameras to avoid having blind spots. And especially if you want precise tracking, like if you want to have something like this, or if you want to track 3D rotation very precisely, we would recommend adding some more cameras. But if you want to just track my general position, if it's okay, if you have like small variations in position, then even minimum amount of cameras will be enough. So when it comes to the number of cameras, all depends on number of factors. Even the factors like the height of your ceiling, because every camera has a viewing angle. So if it's higher, it will be able to cover a bigger area. So how does this? How is this installed? This system? As I said, we need to mount the cameras around your studio, and this is actually the most time-consuming part. So to find the appropriate position and to really fix the cameras so they're not changing their position. And once the cameras are in place, we take this other piece of hardware, which Angela will bring here. Thank you. So this is our calibration cross. So once the cameras are in place, one of our engineers walks with this calibration cross and simply makes something like these waves. And then the system learns from these movements, learns the position of each camera, how they are in relation to each other, and simply calibrates the system. This procedure lasts less than 1 hour. And after that, our system is calibrated, and we are sending the positional data to Pixotope. And from then on, they handle all the other things, and they can do their magic. And your designer's work also comes to life. So I'll bring this back. So as you could see, that even if you have amazing camera tracking, there were some limitations that you couldn't do. With this technology, you can do much, much more. And it's like literally the imagination of your creative team is what defines what will be possible with this. One other thing I will point out is that this technology is so precise and powerful, has a huge potential that we can actually even track the camera itself with this. So we simply add some of the LEDs on top of a camera, and we can even achieve camera tracking. So with this one solution, follower, you can track your camera, you can track people, objects. So you simply need to have follower cameras around the studio, and then the cheaper part is the LEDs itself, which you can have so many functionality, like I said, camera tracking, object tracking. So that's it from me, guys. I'll be here later for Q&A. My colleague from the support team, who has a lot of field experience, is also here, Dado. So for all the questions, we are here and should be able to answer. And now, David, you can take it away. Andreas, once again, hi.
All right. Thanks a lot, Ivan and Angela. That was great. So next, let's take a look at how we configure the follower system in Pixotope. And for that, we're going to zip over to London, TFG, and hear from my colleague, David Stroud. Let's
hi
see.
there,
David.
Andreas.
Yeah, hi. All right. You can hear me. That's good. I'm going to let David show us how it's done.
Oh, thanks very much. And thanks to Ivan, Dado, and Angela at stYpe in Croatia. That was really interesting. So just moving on here, I want to introduce myself. Some of you will know me. Senior Product Specialist at the Future Group. I've been here just over a year. Worked on plenty of outside broadcast projects around the world. Previously worked at NCAM for a while on Filmlight and lots of other places over the years. But today, what I want to do is talk about how we integrate stYpe Follower into the Pixotope environment. So I want to show you this slide. This is effectively what we have in the studio at the moment. We have 4 cameras, and the follower units are within that volumetric space. We then take the data from the cameras, it comes through the stYpe follower box, and it's passed across to the Pixotope tracking server. Then once we're in the server, what we have to do, there's 2 configurations that have to be set up. First of all, we have to take the data streams coming in, and each follower is talking on its own port, so UDP ports. So we have to configure those with logical assignments. Then we come into the editor and we assign those logical trackers to actors within our 3D, within our Unreal scene. So that's essentially what we're going to go through. As I go through this, I'm going to be showing you an emulator here. At the moment, we're using Pixotope 1.21, which is released, it's hotfix release that we released last Wednesday, so 29th of April. It's based on Unreal Engine 4.23. In this version, we've manually configured the ini files so that to put all the followers in. But in version 1.3, which is our next release, which is going to beta later this May. So if you're interested in that, please get in touch and we can work out betas on this. But that's based on 4.24. We've integrated the follower interface. So that's what I want to take you through now. We'll just zip across to this screen and hopefully I can take you. So in Director, first of all, we're going to set up the mapping. So for those of you who've not seen the Pixotope interface, this is the Director interface with the setup panel. So we do all our physical assignments in this panel. Those of you who know it will recognize pretty quickly that the camera tracking panel and the object panel have been combined together here. And we've got a new panel called Object Tracking. So what do we do? First of all, we want to create a tracking group. So I click on here to enter the name for my tracking group. Now, tracking group is an assignment of followers that are coming in. We're grouping them. It's a logical assignment, but followers that we want to keep together. We might have a lot of followers in a scene. So this enables us to split them up into individual groups and manage them more easily. So if I add that in, you can see in my interface here, we've already generated 2 tracking groups. We can also add many more if we wish to along the top. But anyway, for my object tracking group number 1, I have to assign my tracking server. This is the first box that you saw, the camera tracking server. So this is the physical hardware or piece of software that we're talking to that's receiving the network communications from the stYpe follower. That done, we have to assign each of the individual followers to a logical name. So I add an object tracker here, we give it a name and the port that it's associated with, and then we add it to our list. So what you can see here, when we name these, we've named them logically for elements that we're going to use in the scene. So the talent tracker, the tablet tracker, the pen tracker. We can also, and here's the port address as well. So we can go in after we've created these, we can modify them again, change the name, change the port address, or delete them if we wish. So that defines all our incoming trackers to the system. But we also have to talk the right protocol. So in here, as with our camera tracker, we have a tracking protocol assignment. This is a drop-down list with just stYpe follower tracking protocol. And here we assign the physical attributes to that. So the real world units, we're taking distance in meters, rotation in degrees. And these are the assignments of our 6 degrees of freedom axes. So our position XYZ and our rotation XYZ are mapped to the correct axes within the Unreal environment. So we do that for each of our object trackers. And then once we've got that, we also, like with the camera systems, we have the ability to apply a calibration offset. So if I go to the calibration tracking here, you can see there's my cameras and this particular object tracking group. I can assign physical offsets and rotations to that group. Now that affects every follower within that group. So this is another reason why I might want to break up my objects into different groups. If I want to apply a specific offset to a bunch of followers, then that helps me. Having done that, we then need to think about syncing. And here we get the ability to change the tracking delay relative to our render process. So we can delay the tracking data coming in to match up. So that completes the setup of the tracking group. We want to go back though and have a look at how this works and how everything is set up in our routing panel. So this is our standard input and output routing panel. You can see my talent, tablet, and pen values here are assigned, plus my camera inputs and also my outputs. But there's a lot of data there. It would be nice if we could just section that off and look at the incoming data only. So here's my camera inputs, here's my object tracking group, and here are my assignments to my object trackers. So the talent, the tablet, and the pen. And also I can change the port addresses here as well. So I went through a couple of clicks to do that, but coming back to object tracking here, you can see we've got a shortcut which takes me directly to that menu if I wish. So that kind of covers the setup in Director. That's the logical assignment of all my followers coming in and assigning them into the system so that I can access them. I did want to just mention and go back to the camera tracking panel, which we've changed. And this is for those of you who know Pixotope already. You can see that we still have the camera assignments at the top, but now we've included the camera tracking panel assignment here. We then have our setup for the camera. So that's the film back and the aperture. And then finally, down at the bottom, we have the protocol assignment and the advanced values, like whether we're going to be handling distortion, whether we have focus distance enabled, and offsets for a particular camera mount. So everything to do with the camera now is held in one, and the tracking of that camera is held in one panel. So that completes a bit of a look through of 1.3, the director side of it. I just want to go back to the beginning of the simulator here and show you what happens with the editor. So we'll just click into there, and you can see this is a stylized Unreal interface. This is not the editor. I know you can appreciate that. But what we want to just show is the process that we go through. So assuming that I have an object in my scene, I would select it and click right on it. If I click right, there's an element to that menu which is Pixotope specific. And within those, you will see that there's an option at the bottom, which is to follow the object tracker. So if I click on that, three things happen. I create a null object as the head of a hierarchy. So we call this, in this case, it's been called cube root. But supposing I had an actor, I don't know, Fred maybe, and I clicked on Fred and assigned a follower to him, there would be an object called Fred root. Fred would be then associated with that root, so placed underneath that in the hierarchy. And we would also assign the tracker to that same root. So immediately by doing that, under the Fred root, we would be able to move our object directly in the scene with the object tracker. Let's look a little bit at the right-hand panel here and what options we have. So we can select which object tracker we're going to assign to our actor, and then we have an enable control. So this is kind of nice because we can turn off tracking or turn it on at any time. This can be exposed and handled through the control panel interface, where we could turn on the tracking or turn it off at will. Down here, we've got our 6 degrees of freedom assignment. Now, at the moment, you can see here, we've just assigned XYZ position, so we can track the position, but no rotations. One thing I should mention is while we show all the channels here, you will only get 6 degrees of freedom if you have multiple LED beacons attached to a follower. If, as you saw with Even, he had the single beacon attached with the mark across, then you can only get the position. So you need the extra beacons to give you the rotations. But that's pretty much what we've covered here. We've covered setting up in Director. We've covered assigning our object trackers in the editor so that they move within the scene. And now we're ready to see what we can do with the technology. One thing I'd say as well, before I move on, is any questions that you happen to have, please enter them into the questions panel, and we'll come back to those at the end of this session. But that's it for me, Andreas. I'm passing back to you now, if you'd like to take over.
Thanks, David. That looks really straightforward. But again, if any of you in the audience have any questions, just use the Q&A panel like David said, and we'll get to it at the end of the session. I also see we have some people who've joined a little late. Don't worry, if you've missed parts of this, we'll make a recording of this whole session available later. Okay, so now we know how to set things up. Let's take a look at how the stYpe follower and Pixotope can be used together in a creative context. And to do just that, we have with us Danny and Berto from All of It Now. They're a creative agency specializing in real-time content design and workflows. Let me see if I can fire you guys up. All right. Can you hear me?
Yeah, I can hear you. Can you guys hear me?
Yes, excellent. You're a little distant though. Check your sound.
Hey, can you guys
Hey guys, just here
Sounding much
during
better.
the demo. Okay,
Excellent.
great.
Okay, I'm gonna let Danny and Berto take it from here.
Hi guys, welcome. We're here live in our first virtual setting. We have here kind of a sci-fi environment, and we're showing off, first of all, the ability to move around that environment in using stYpe's red SPY. We're here joining Berto, who's going to demonstrate some of these follower beacon examples right now. And Berto, take it away.
Hey guys, thanks for joining. My name is Berto Mora, and we are here, or I'm here on behalf of All of Now. And today we're going to do a little demonstration of the possibilities of follower within the Pixotope engine. As you heard from Ivan over at stYpe, he showed you guys the setup of how to set it up physically, and then David showed you guys how to implement it within Pixotope. And we are now going to show you guys how to actually use follower within Pixotope. It's going to be more of a technical demo and demonstration. In some cases, you might see, the illusions being broken, but that's kind of just to show you guys the magic of how this is made. So first off, I want to thank Pixotope for allowing us to be a part of this demo. We're really grateful that we're allowed to do this with them. Also, our sponsors, Ari, stYpe, and ProPsych, thank you to them. Without them, this demo would not be possible. And we're taking all these technologies, incorporating them together to provide you guys this demo today. So we're talking about object tracking here. And one of the first things that I'll show you guys is how you can actually use follower, one single XYZ beacon to actually track objects within space. So what we'll do here is I will show you this object. This is just a little, moon that we put together, but we are now tracking XYZ of the space here. And what we can do is we can kind of also occlude the subject. So if I do a little 360 here, you guys can kind of see that the object is being occluded. And this is all possible because we are able to track the talent as myself. I have a beacon under my shirt at the moment. And we're also able to track the 3D object in space. So based on that relationship, we are able to do occlusion when you include the ProPsych green screen along with the Pixotope compositing planes. Pixotope has a lot of amazing compositing planes. I mean, one thing that I really like about them is that I can actually set compositing planes to actually grab the desk. So as you can see here, I'm grabbing the desk. Another thing that you can do is we're going to take this prop here. And what we do with this is we actually make this as a trigger animation beacon. So we've had some trigger boxes within our desk here. And as I place it in a specific area, you now see that our door is being open. And that is being caused by the XYZ data of the beacon entering a trigger box. And we have now opened an animation sequence that opens up that door. Another effect that we have is we have a virtual hologram. So if you see the beacon here, we're going to use the Pixotope control panel, and we're able to create buttons to actually toggle animations on and off. So that's kind of another effect that we can do. We can have virtual props moving around. This one also does occlusion, which is amazing. We're going to set that guy down, and he's going to go away. And another example that we have here is a rigid body. So a rigid body is actually made out of multiple points of tracking. So here is a stYpe tracking pack. This one has 6. They make some with 4. They make some with 1, and we even have one with 12. So you can imagine how complicated your rigid bodies can get. Obviously, the bigger the object that you're trying to track, the more tracking points that you need. So in this case, we have this rigid body. We have the Tesla Cybertruck, which is probably one of my favorite cars created today. And if you can see here, I have this black box that has 4 beacons attached to it on each corner. And what we're able to do is we're able to tell the Red SPY, or should I say the follower software, how many beacons we have in space and how many of those beacons belong to a rigid body. So then we take a snapshot of that to create that rigid body, and then you can now parent 3D objects to that, as you can see here. So that's a really amazing feature of the follower. So what I'm going to do is I'm going to actually go ahead and close this door by just triggering on again, and you can kind of now see the animation triggering off. So for this scene, we're pretty much done. Another thing that I want to talk to you guys about is, as you can see here, is the actual Cybertruck is occluding me, and I'm occluding it. One of the things that Pixotope provides is they have materials that actually deal with alpha. This is something that I've had a lot of trouble just using Unreal Engine natively, but with the Pixotope engine, we're actually able to use their specific materials and object occluders to kind of create this effect. So I'm going to switch over to a video that I've pre-recorded that's going to kind of demonstrate real quick how you can set that up in your project. It's going to be quick. It's about a minute. So Danny, if you can switch to that, that would be great. And if you can see here, we're in the same scene. And what you can see is I'm adding the Cybertruck into the scene here. I'm going to position it kind of where I want it. And I'm going to make sure that it's all, sized correctly. And if you're noticing, a lot of these, or Pixotope is, Unreal Engine flavor that they've created with amazing tool set to do occlusions and things like that. So the next thing we'll do here is we're going to apply my texture after I adjust it. And you guys are going to quickly see once I add that texture, how that texture is not occluding my subject behind it. And what we'll do here is we'll just kind of take a look, and yeah, it's not occluding it. We're going to trigger the door to kind of showcase that a little bit more. So now you can see that anything behind the Cybertruck through this beacon is not, recognizable. So if you see here, you right click on your object and you convert your object to translucent. And now Pixotope has added that object within their render pipeline that supports alpha so that you can do this composition plane. So that's a little bit on how you do that. This material we've created is just a normal transparent material. So, you can see how we converted that object into a transparent object using the material I have created. So yeah, so that's a little bit of how you do that. I'm going to let Danny kind of show you something else within our demo, which would be a video here. And yeah, Danny, if you can take it from here.
Yeah, thanks, Berto. So we're going to show here another example that is more of an AR approach. There are sometimes situations where we don't have access to a green screen. In that case, we can still use Pixotope and Follower and RedSpy together to create an AR experience that essentially is purely augmented reality, where we're using the existing backgrounds, existing camera feeds, and overlaying content on top. The same follower beacon occlusion concept doesn't quite apply here, but you can still create some dynamic content. And we're going to see also the ability to show some really clever ways to combine multiple beacons together. And we're not talking about a rigid body here. We're actually talking about using multiple single beacons where you can actually have a beacon move from an object move from one beacon to the other. And so this is a fun example of how to have multiple presenters in the same environment. This was recorded pre-corona and pre-social distancing, but in the event that you do have multiple presenters, they can interact together and create some really clever experiences. There's some, fun, concepts beyond butterflies. The kind of possibilities there are definitely endless. We had a lot of fun with the butterfly because in this case, we're using the look at parameter to essentially drive the position and rotation of the butterfly. So as we move the beacon around, it can actually kind of simulate what a rigid body might do. And so that's a kind of really clever application of what can be done with Follower and Pixotope used without a green screen. That said, the green screen is way better for any sort of concepts requiring dynamic occlusion, and we can kind of show some more of that in this example here. In this example, we've got an example of the performer moving both in front of and behind the dynamic object, which is again still transparent and still kind of a holographic example. So as you can kind of see, they're moving all the way around, and we're using a similar kind of look at parameter here so that the mannequin can follow our on-screen talent and be able to occlude and be occluded dynamically. And with that, I think we are just about ready to move into our second demo. And this is where we're going to be showcasing a little bit more of the drawing examples. And here we go.
All right, guys, so we're back. Hopefully you enjoyed those videos that Danny presented. So in this scene right here, as you can see, we are using an Unreal Engine scene directly from the actual engine store. And one of the cool things is that the graphics that we're showing you today is some of them were made in-house, some of them were made through other users. And we thought that this one was really cool, so we started using it. One thing to know as well is that as you're doing these kind of projects for your virtual production shows, you want to make sure that you have game optimized assets, because if you don't have game optimized assets, that will definitely bring your performance down in your engine, and things will start to become interactive instead of real time. So one important note there as well is you want to make sure that when you're making your content in other engines or in other 3D engines, you want to make sure you want to do some testing of either performance, either axes. As we know, the Z axis in Unreal is up, where in other engines, Z is back or forwards. So that's just a couple notes that you'll have to do to test your content to make sure that everything is working properly. So in this demo, what we'll do is we'll actually show you guys the stYpe follower. And if you can see here, I have a little sphere that's being tracked on my pen. So the stYpe follower is always being tracked in real time. And the cool thing about the follower pen is that it actually has a button that enables you to turn on and off, turn the graphic on and off. So if you want to start drawing, you press the button. If you want to stop drawing, you release it. And in this case, we're just going to show you a demo of how precise that follower pen is. And we'll go ahead and start drawing here. So what we're going to do next is if Danny can show you guys our actual control panel, you guys will be able to see our control layout for this scene. We're going to go ahead and clear that now, and we'll show you kind of what a control panel looks like within Pixotope. So here what you see is we've created a couple buttons. This control panel is, we have a couple different scenes within this control panel, but if you can look where it says spline color, what I was able to do is I was actually able to create a material collection that actually talks to the material so that I can actually have access through those those parameters through the follower control panel that I've created within the Pixotope control. We've also have the clear drawing, so we've added buttons to kind of clear that drawing. And you can do a variety of different things within the control panel, which make it a lot easier. Sometimes I use OSC or I'll use different surfaces, but it's really, really nice to have it integrated within the system, as you can see here. Great, so as you can see here as well, we can actually also occlude. So you can kind of see how I can draw around myself. And as I mentioned, the only reason we can do this is because we have green screen at the moment. You can see how I'm occluding the object. So if I walk through it or walk in front of it or behind it, you can start seeing the occlusion there. So we can also do a little, very fine drawing. I tested this and it, you can draw a lot and, the system doesn't, bog down, which is really, really nice. As you can see here, you start seeing my hand being clipped. The reason why is because I have an occlusion plane on me. So if we clear the graphic here and I put my hands out, at the moment the camera's too close to me, but as I get closer to the camera, you can kind of see where that is being cropped off. And that is actually the composition plane that allows me to occlude the graphics as I'm doing here. Yeah, so this is kind of the follower demo that we have with the pen. And we're going to reset. Danny's going to show you another video that we've created. And yeah, hopefully you enjoyed that. And I'll be back soon.
Okay, so we did another kind of AR version of this drawing to where if you did not have access to a green screen, you can still create this drawing application. And because we had a little bit more space in our studio before we had the green screen, there is the ability to kind of have more freedom with the camera and really show off some of the depth here. So kind of as you saw Berto drawing here, you're able to move that camera, pick it up, and with handheld fly through a 3D drawing, essentially. You could think of it as a kind of tilt brush on steroids or something to that effect. It's really, really fun, incredibly intuitive. You don't need to be a master artist in order to do it. It is, essentially just takes a little bit of practice understanding that you're not drawing on a 2D plane, but actually a 3D plane. You can create really interesting optical illusions. You can create really clever drawings that maybe accentuate or call attention to a specific moment or scene or position. This can be used, beyond the creative method and be used more informationally, so that a presenter can really illustrate their point, quite literally. There are a lot of really fun applications of the drawing application here. And what we're also going to show in the next scene that's pretty exciting is the ability to use some of those follower beacons, not just for the control of objects, but also the interaction with physics objects. And that's really exciting because you can have physics and lighting interact both physically and virtually with your on-screen talent. So the guys are just setting that up right now and just taking a moment here to kind of really enjoy this AR drawing example. But we're in this example, because we don't have that green screen, we're not able to get that kind of dynamic occlusion that we saw earlier. So there are limitations to not having a green screen in this case, but this is where you'd want to use, your kind of the creative applications and creative concepts to work around some of those limitations in the event that you don't have a green screen. And I think we're just about ready for the next section here, and I'm going to hand it back over to Berto.
Hey guys, thanks for coming back. And so in this scene, what we have is we're going to demonstrate you a little bit of rigid bodies. As you can see, I have a rigid body saber here. We also have this Fortnite pinata behind me that's actually hanging. So one of the things that, another thing that we'll showcase here is also how we can have physical and virtual rigid bodies along with physical and virtual light control. So we'll kind of demo that throughout this demonstration. But as you can see here, I'm in the scene. I have this rigid body of the saber. What I'm going to go ahead and do is I'm going to step back a little bit, and I can now interact with this pinata. So what I've done here is I've actually added a bounding box on myself based on the follower tracker, and that's tracking me along with the collision body. And you can kind of see how I can kind of interact with the pinata. And also we have occlusion here, so it can occlude me in the front. This is where it gets really interesting, is when you actually have a rigid body and you start interacting with virtual props, with physics. So I'm going to go ahead and kind of toggle that, and you can kind of now see that pinata, actually swinging in 3D space. I can occlude it. It can interact with me because I have that collision body, which is pretty incredible with the things that you can come up with by using just the stYpe follower system. Another note here is we're actually using the red SPY as well. So the red SPY is the camera tracking system that is allowing us to zoom in, focus, and also create the augmented reality effect. So I'm going to go, maybe hit this guy a little bit more. Yeah, he'll bump into me. So the next thing we'll do is I'm going to set the saber down, and we're going to pan over to the light. So we're fortunate enough to get some demo sky panels from Ari, and it's very, very exciting. These lights are all DMX controllable, which actually allows us to control that data via a console or via some software that supports DMX. We are currently using MA for that, and we're also using a software called Stage Precision to kind of give us lighting data into Pixotope via the MA software. So we're able to forward that data to the virtual and physical light. So if you guys can see here, I have this virtual sky panel, and just a note here as well is this section here is where the tracking bounding box is. So you can now see where our studio is. Here's a physical light. I'm going to go ahead and move that light, and if you can see that light, I'm actually turning. We've attached a rigid body follower tracking trackers on here, which is why we can get the rotation. We can also, change the colors. So if Neil changes the colors, you can kind of see how the physical and virtual light changes color. And another cool thing is now that we have this all rigged up, we can actually pan to the piñata, and we can actually see that virtual light also being casted onto our piñata. So if I move the light away here, and if I move the light back, you can kind of see how I'm showing that light casting onto the virtual piñata. And that's all being done with Follower, and also the amazing integration that Ari has added to the Sky panel to be able to control that via console. So another neat effect here is that I can actually walk in front of the piñata and occlude it with a shadow. So as you can see my shadow there, that is being casted from that light onto the piñata. So you can have really, really, really nice occlusion here. So yeah, so that's, that is going to conclude our demo here of all these ideas that we've created in the past few weeks. And, we've been testing this technology for, a few years now, and really happy where it's come along, because now, we're able to do these demos so that people out there can actually start doing this work themselves as well. So, I really want to say thank you to Pixotope for allowing us to do this. I want to thank, Ari for, donating our lights, ProPsych for letting us use the green screen. And I really, really want to thank Danny, Neil, Izzy, and the rest of the All Done Out team that has a lot, helped me to put this demo together. And I really hope that we can also, start producing more demos for people and more ideas. If you guys have any questions, please email us at info@allofitnow.com. Also, Pixotope will be sharing a list of emails. So if you need any Follower or any stYpe related questions answered, you can email them. ProPsych as well. They have amazing green screens. We've tested other different types of green screens, and this one by far has been one of the best ones we've used. And also Pixotope, their amazing occlusion passes that they've added and composition planes have made it so much easier for me to be able to put this demo together. Whereas I mentioned trying to do it in native with native software like Unreal, it's much harder. But thanks for everyone that joined today, and I'm going to pass it back to Pixotope here. Thank you guys.
All right, thank you, Berto and Danny. This is super cool stuff. All right, great. So we have a couple of questions. And the first one is, I think for stYpe, it says, when calibrating, do you need controlled lighting? And the use case for this is thinking how this might work in a live setting for live music. He's worried about getting a clear stage for an hour to do the calibration. So Dado, maybe you can explain how we could use the stYpe follower in a live AR setting.
Sure. So for the setup, we would need some stage time as well. So pulling all the cables and mounting the cameras and calibration of the system itself. It should take, depending on the cabling, up to an hour. But after that, yeah, we're fine.
Right. Does it have any specific lighting requirements, or does the calibration and setup not require anything lighting because it provides its own?
Yeah, correctly. Since we are using active beacons, we don't require any lighting on the stage itself.
Great. Okay. Yeah, hope that answers your question. Next up, let's see. Question about object tracking. How far apart do the 4 beacons need to be to track rotation?
So for the object tracking, depending on the distance between the camera. So let's say if the camera is up to 4 meters from the tracked object, we can do with 10 by 10 centimeters by 10 centimeters of rigid object. Yeah. If the object is,
sorry, yeah,
2.5.
Okay, right.
2.5, yeah.
Yeah.
But if the camera is further apart, then the rigid object or the distance between the LED beacons should be greater. Yeah.
Cool. Okay. So it depends a bit on how big the object is and how far away it is from the cameras, basically.
Exactly.
But,
yes.
Cool. Let's see. There's a question here. Can you make someone has a question about the, let's see, the Cinema Lugon plugin for the Unreal Engine, and that actually sounds like an SDK question. David, do you have any information about plugins used in Pixotope?
Yeah, so in order to use plugins in Pixotope, we just need to recompile them for Pixotope. So that's something you can do. We have an SDK that you can download, and you just need to install that on your machine and have Visual Studio installed. But it's a very simple process, assuming that you've got source for the plugin. So that can be recompiled, and that will work straight away in Pixotope. It's pretty straightforward. We can do it as well, but it is entirely up to you. That SDK is freely available.
Yep, it's the SDK is free. You just have to sign a license agreement, basically, because it gives you access to the source code for Pixotope, and so it's to prevent you doing anything nefarious with it. But like David said, you just need to, you can recompile the plugin, but you do need access to the source code for the plugin as well. So you can't just download it off the marketplace, unfortunately. All right, next question. Do you determine what type of tracking the follower markers are in Pixotope, or are they predetermined by stYpe?
Can you repeat the question again, please?
Yeah, I think it's asking, do you determine what type of tracking the follower markers are in Pixotope, or are they predetermined by stYpe? I think the question is, when you buy the markers, are they just generic markers, or do you have to buy specific markers for position and specific markers for
I can take this one and pass to Dardo, but I think the beacons, the LED beacons themselves are all the same. And then you just plug them onto the follower unit, and the number that you configure on the follower unit determines the degrees of freedom that you get. So with a single beacon, you just get 1 degree of freedom. With 4 beacons and positioning them on a rigid body so they don't move around, then you'd get your 6 degrees of freedom. So the configuration of those objects is in the stYpe configuration, and we just see a tracking stream, and we either what we get in that tracking stream is either the XYZ position or XYZ position and rotation. Is that correct, Dardo?
Absolutely correct, yes.
Yep, great.
That was a good guess.
Next up, will you be covering the workflow between Unreal Scene and Pixotope? We actually have a Pixopalooza seminar on this. I think it's number 6, but just get in touch with, I think I've left the email addresses for the TFG contacts. So just get in touch with one of those guys or ladies, and they can hook you up with a video recording of that seminar, and they'll walk you through what the workflow is like when working inside Pixotope and how it compares with working with Unreal. I hope that answered your question. There's also a question, when will the video of this webinar be accessible? When it's ready. We'll try to get them out as soon as possible, but there's some steps that happen downstream. We have to transcode it and upload it and edit it a bit and stuff, but hopefully within a couple of days. There's a question here, when using a real virtual fixture like the sky panel, can we account for different diffusion options or focus if relevant? That sounds like a question for you, Berto, at All of It Now. Sorry, can you hear me?
Has he got his mic on?
Is your mic on? Let me see. I think you might be, I'm not sure you have your sound on, Berto. Let me see. No,
I'm
there
on.
you go. Perfect, you're on, great. So the question was,
Great.
when
Sorry,
using a real virtual fixture like that sky panel, can we account for different diffusion options or focus if relevant?
Yeah, you can actually add, you can add all of that if you really wanted to. It's right now the way we're doing it is we're adding an emissive material to the actual virtual sky panel. But within that emissive material, you can also add different types of diffusions or different types of, light casts, so you can represent that light a little bit more. So it's up to your light, and it's really up to how you build it. We just took like a raw, sky panel 3D model. We added the emissive texture on there, and we did the control of the color and the position with that. Position was done with follower, and the color changing was done with MA and stage precision to kind of control that in virtual and physical space.
Great. Let's see. So next question we have is, does it work with back projection screen and LED screens instead of green screens? I'm not an ops person, so hopefully someone can weigh in on how we might possibly solve that.
I can take that and bring Berto in as well. I think, yeah, so if you haven't got a green screen, what you're suggesting is you use an LED wall, and then you turn the LED wall green in order to be able to work. Or are you talking about in terms of it may be that you want to put an actual image up there. So if you turn it green, then of course you can use that to key out your foreground. You have to be careful with LED walls and using them as key sources, as green sources, because of the dot pitch of the LEDs. But if they're fine enough pitch, then you could get a key from it. Otherwise, if you're just going to use it as an image layer, then you're not going to be able to segment your foreground. So you're not going to be able to do the same sort of nice occlusions that you're able to do on the green screen. Is that correct, Berto? Is that your understanding?
Yeah, I mean, we've also done some LED work. I mean, the toughest part about doing LED is it's really hard to separate your subject from the LED wall. I've seen some tests where people have used depth cameras to do that masking. So as long as you can get a mask of your actual subject or whatever you're tracking, you're able to do that. So, you know, with some depth cameras, you might be able to, you know, extract the subject, and then you can kind of start doing that within the engine as well. But yeah, I think it is possible, but yeah, you somehow, you know, you need to essentially key out or mask out your person so that you can do these composition effects, which is why the green screen allows it, you know, because you can key that person out and you can use the alpha of the green so that you can start occluding objects within the 3D space.
And to add to that, kind of like what David is saying, with an LED wall or a projection screen, it has a lot more of a transmissive, you know, property. So it is more likely to cast green back onto your talent, and maybe a little bit harder to work around compared to a more conventional green screen. You know, essentially, you're just going to have to increase the amount of brightness on your talent to kind of compensate for any green spill from your essentially green light source that is coming from your projection screen or your LED wall.
Yep.
Okay, gotcha. Next question, how does stYpe calculate XYZ data or 3D space? They don't specify if it's talking about red SPI or followers, so maybe you can answer for both. And the specific question, does it need a constellation up in a grid like other competitors? And how well does it work in a wide or big open space? So Dado, I think this is for you.
Yes, thank you. So markers we use for the optical tracking, which is red SPI. So we do need the constellation, but it's a random constellation up on the ceiling or down on the floor. So the system works on, so it's our proprietary system, but it's based on a very old system, which is just a second. Sorry about that. VSLAM protocol for the optical tracking. And with follower, we are using multiple cameras to see an object, and it calculates its position in 3D space.
Right. So the follower does not require a grid like the other competitors, and like you said, the follower could also be used for camera tracking. So
Exactly.
maybe
Yes.
that might be a solution if they want to avoid the grid. Great, thank
Correct.
you.
Yes.
Let's see, next one. How are these beacons tracked? With static cameras, how many tracking cameras do you need?
So the basic kit is there are 4 cameras included in the basic kit, but that also depends on the size of the studio or the area that you want to cover. So for the bigger area, let's say 10 by 10 meters, you would require at least 8 cameras. But for normal usage, 4 are more than enough.
Great. Question, I think for David, is there workflow differences between broadcast workflow and filmmaking workflow?
There are quite a lot of differences in workflow. Obviously, film workflow is shot-based, whereas broadcast is generally for live consumption or live to tape. In terms of, so those are the generalized setups. In terms of what we're doing here, that comes down to camera rates, whether we're running at 24p or we're running at broadcast rates, we're running at interlaced or progressive. But those are the main differences, really. Film cameras are typically prime lenses, but that doesn't affect us at all.
Yep. And can you speak to frame rate for the tracking data? Noticed 50 Hertz within Pixotope. Can the system plot data beyond 50, 60 frames per second?
Okay, so the standard rates are up to 60 hertz. What you saw in the mock-up was just the fact that we put 50 hertz into the mock-up. That would be, you would set that up dependent on your line frequency. So I'm just harking back. I mean, Dado could take this in terms of tracking frequencies, but typically what you want to have with your tracking system, you want to be tracking or providing samples at your refresh rate for your frame. So you get a sample for every frame that you're displaying. Otherwise, you wouldn't get smooth motion. And you certainly don't want to be tracking at 50 hertz in a 60 hertz environment, because then you're going to get cadencing in the movement. So the general rule of thumb is you always use the line frequency for your tracking. Is that your understanding as well, Dado?
Yes, absolutely correct.
Great. A question for David again. What is the roadmap in terms of updating the Pixotope software to the latest Unreal Engine?
Okay, good question. I did cover that earlier in the presentation. We try to track the latest version of Unreal, but of course we allow it to settle for a while. You'll find that the recent releases, they come out that no one's going to jump on it immediately and certainly not use it in production. So there tends to be a bit of a lag. We started supporting 423 in mid-February, I think, if I remember correctly. And our next version is 424, which is going into beta, as I say, later this month. So we tend to be a little bit behind the curve, but typically, if you're going into production, you're not using cutting edge for live productions or for broadcast productions. So you want something that's going to be stable. And we try to allow the time for things to be. We don't necessarily want to be the first to find a problem in the Unreal environment. So we like to let it stabilize a bit. I think that's being kind as well. You know, that's it's nice to be on the cutting edge, but it's also nice to be safe.
Yeah, you don't want the bleeding edge. That's too far.
No, exactly.
Let's see. So, question actually possibly for Berto. Can you migrate blueprints with viewport actors of blueprint logic previously created in Unreal Engine vanilla to Pixotope? And a second question, can you create and use custom C++ based actors in Pixotope, for example, for loading a large number of resources from the hard drive at runtime? So maybe, Berto, if you could take the first one. The second one sounds suspiciously like another SDK question. But,
Yes,
go ahead.
yes. So currently the version of Pixotope that we're using is 4.2.3. So we've done a lot of testing. Most of the stuff from 4.2.3 vanilla Unreal transfers over to Pixotope. It just depends on how complicated your graph is. But we've also done tests where we bring in 4.2.4 blueprints, and those also do merge. One practice that we do with that is we actually copy and paste the blueprint into a text file, or you can just have both of your engines, 4.2.3 or 4.2.4 open and Pixotope open. You can copy and paste your graph or your node graph blueprints and then bring them over to Pixotope. That transfers pretty well. Something that I found out is I have to recreate variables, which isn't the worst thing in the world unless you have hundreds of variables. Unless someone has solved that, please let me know, because I've been trying to figure that out as well. But yeah, most of the stuff does transfer, and specifically if it's 4.2.3, that's where you get the best results. But as well, it's all about trial and error, you know, depending on what you're using. Maybe some of the code that you're using in 4.2.4 is the same as 4.2.3, so you can transfer that over. But it's when you start using either something that has changed or like a new feature that's not being supported on that end. Another thing to note is all the plugins have to be specifically compiled by Pixotope in order for them to work in that engine. So you can't really just export or copy and paste a plugin from either 4.2.3 or 4.2.4 into a Pixotope engine, because that's not going to work. They have some sort of special wrapper that they add around that so that it can actually integrate with Pixotope.
Yeah, and a consequence of that, just as pointed out by my colleague Frank, if the blueprint relies on logic from third-party plugins, those plugins need to be compiled for Pixotope. But other than that, it should be fairly straightforward just to open it in Pixotope instead of Unreal, provided the versions are the same. Great, thank you. Let's see. Is stYpe dedicated to indoor studio environments, or can it be used also for outdoors and spaces like stadiums? Are there any physical limitations of the system?
I presume we are still talking about follower here. So let's say the range of the cameras is up to 25 meters. So stadium is a bit bigger than that. So we cannot cover really large open areas. Like smaller ones will be more than enough. So we did actually work with Pixotope. We did cover a concert with follower, actually with guys for all of it now, sorry. And it was working on a live broadcast outside.
Yep. In regard to occluding the light and casting a shadow, is the keyed camera feed applied to a 3D plane and the 3D plane is following the object tracker? So Berto, maybe you can answer how you set that up.
Yeah, sorry, could you repeat that again? It's hard for me to hear.
Sure. In regards to occluding the light and casting a shadow, is the keyed camera feed applied to a 3D plane and the 3D plane is following the object tracker?
Yeah, what we're doing there is, as you can see here, I'll step to the side, and you can now see this plane as I mentioned earlier. So you see the plane there where it's cropping me. What we have there is we have a 2D plane in 3D space that is the Pixotope keyed out composition. And what we're able to do there is we're actually able to track that in 3D space. As you can see here, that plane is following me. And right now, I'm because I have the beacon on my chest, I am in front of the virtual pinata in 3D space. But as I go around it, I am now in front, right? Obviously, if you had a bigger green screen and a bigger space, you wouldn't get the clipping here. Our green screen's a little smaller, so it's a little hard to kind of get the perfect occlusion here. But yeah, that's what we're doing. We're tracking the 2D, 3D plane in 3D space. And since everything is in 3D space and everything is, accurately scaled, those are the things these are the effects that you can do. One thing to mention is, yeah, make sure that all your scales are proper. Because yeah, if say this pinata is 10 meters, but it looks like it's here, it might be very, very far away from me. Or what can happen is that this pinata can be really, really close to the camera and be really tiny. And now when you're trying to occlude it, it doesn't work because of the scales are off. So that's just very, very important. In order to do these effects, you have to have scale exactly precise. Like we have tape measures, we have everything to do to measure everything. The desk that you saw earlier, we measured that properly, the height, the width, all of that. If you don't get that properly correct, you are going to have a lot of trouble trying to match the virtual and physical world together.
Yep. Just also building a bit on that, the comp plane, we call it the composition plane, but it can be any kind of 3D shape. So there are use cases where cylinders or more complex geometry is also more suitable for a good result. And also depending on what kind of camera angles you want to use. So you can actually make any sort of shape into a comp plane, but traditionally it's just a rectangle. We also have a question about, can you discuss a stYpe implementation for virtual production in place of a traditional optical system such as Vicon or OptiTrack as it relates to prop tracking? Dado, did that question make sense? David?
Yeah, so it's a suggestion that we replace OptiTrack and Vicon for object tracking.
Yeah.
It's a similar concept. So obviously Vicon and OptiTrack are specialists in motion capture and high precision motion capture, and it's a different cost of entry. So that would be, to me, the difference in this. Obviously in Vicon and OptiTrack you can track markers, you can track markers on a suit, but typically they are static markers. This is really something, maybe Dado, I don't know if you want to compare and contrast.
So we didn't get into motion capture yet, but I think we are looking into it. So I think those are competitors. I haven't had any chance to see how it works, so I cannot judge currently.
Yeah.
Right.
So it depends on the usage you're putting. Obviously with the beacons in the follower, we're assigning a specific position, or we're using that to assign a specific position. If you were doing mocap, you've got lots of spots on a suit, and then you've got lots of tracking points that you're trying to assign to a skeletal structure or whatever.
But you can also use multiple beacons from the follower also for that. But you still need something to make some object not rigid, slightly movable, but yeah, still I think it's doable. So we are looking into it. Yes.
Okay.
All right, I got an awkward one coming up. So David, this is for you. Is there a plan to support other tracking systems and protocols in the future? Sorry, Dano.
Yeah, that's fine. I mean, you know, it's a very open world. In Pixotope, we've implemented about 10 different tracking systems and protocols, and it's really up to the users to decide what they want to use in their, or they may already have something already in their studio. So that's not for us to decide or to mandate. So we support all the regular manufacturers that you know of. We also support 3D. So if you've got anything that supports 3D protocol, then of course you have to do your own lens calibration for that, because 3D doesn't transport lens data. One of the advantages of using stYpe, for example, is they do the lens calibration for us, which of course no one ever really wants to do themselves. So it's great that they do that, and they pass that distortion data down with the position of the camera, 6 degrees of freedom, and the FOV and vertical and horizontal, plus the distortion. So we don't have to do that work, and we really like it for that reason. In terms of other tracking protocols, yeah, there was a drop down the list that said tracking protocols, but as I said at the time when I showed that, it's a list of one entry. So we don't know for the future, but at the moment there's no plans to add to that.
Right, and we should also distinguish between camera tracking protocols and object tracking. So currently we only have one object tracking protocol we support, but we do support a wide range of camera tracking protocols. Great. I have a question about which stYpe tracker would you recommend if I want 100% precision for the follower or the red spy? And his particular concern is actual filmmaking studios with lots of wireless traffic interference. So Dado, maybe you have an idea how we could solve this problem.
So basically, if you want just one camera tracking system, then I would go with red spy. If you want multiple, so if you get 3 or more track cameras, I would suggest follower, because in that case it will be cheaper, more economical, and you will get object tracking as well.
Right. Are any of the stYpe protocols or setups susceptible to wireless traffic interference?
So we have red spy, also wireless version, so it has transceiver and receivers to send up tracking data. Yes.
Right, but you can also use a red spy as a wired solution, and therefore it probably wouldn't be affected by wireless traffic.
Of course. So we have now a new one, so red spy fiber, which uses a fiber connection between the main unit and the camera, and that fiber cable can go up to 150 meters. So you get lots of freedom.
Yeah, great. Let's see. So for Pixotope, how is the development with integration with this guy's media server platform going? Also, is there any need or idea in going down that road at all?
Okay, we are talking to this guys. We talk to a lot of different manufacturers. There's nothing really to say on that at this point, or in terms of direction. So yeah, maybe in the future. We're not certain.
Yep, that's fair. What's the price range for follower?
So starting package, which includes 4 cameras and a single beacon, goes for 54,000 euros.
Right.
Currently, yeah.
Cool, great. Let's see. Any plans to expand the active tracking hardware to include additional button mappings similar to the pen for more interactions of blueprints, or for virtual productions, allowing talent to cue actions directly on their props?
We can make it. We're open to any suggestion, yes.
All right. So like the pen just had the one button, but you can easily make a pen-like object that has multiple buttons.
Exactly, yes.
Cool. And then I think the last question we have, actually, are the follower cameras PoE or power supplies?
They are all powered with PoE, yes.
All right. Great. Thank you guys so much. This is a really, really good Q&A session. I'm going to kill all your cameras now, and then I'm going to say goodbye to our audience as well. Thank you so much.
Thank you.
There's a whole bunch of you. All right. So, let's see. Yep. That's it for today. Once again, a big thank you to Ivan and Angela and Dado and the rest of the great people from stYpe for sharing their technology. And also a massive thanks to Danny and Berto and everyone from All of It Now for that excellent tour through the creative possibilities with Pixotope.